Hey everyone, and a massive, warm welcome back to the channel. To every single person watching this right now, wherever you are in the world, I am sending you the biggest, most positive vibes. I truly hope you're feeling fantastic, happy, and most importantly, healthy today. Take a deep breath, relax, and get ready for a story that will completely change how you look at one of the most common fruits in your kitchen. Now, I want you to picture this. You're in your kitchen, maybe washing some fruit for a snack, and you drop an apple into a bowl of water. What happens? It bobs right back up to the surface and floats there, like a little red or green boat. Now, that might not seem like a big deal at all. It's just something apples do, right? But what if I told you that this simple, everyday occurrence is actually a tiny, edible physics lesson? That this floating apple is hiding a secret about its very structure, a secret that connects to everything from how plants breathe to why some things sink while others float. It sounds too simple to be interesting, but I promise you, the reason behind why an apple floats is a fascinating gateway into understanding some of the most fundamental forces that govern our world. And it all comes down to one simple, incredible fact. Approximately 25% of an apple's volume isn't fruit or flesh or seeds, it's air. That's right, a quarter of that solid, crunchy apple you're holding is actually empty space filled with gas. So, let's dive in, quite literally, and explore the wonderful science behind the floating apple. To really get why this is so cool, we have to talk about why anything floats or sinks in the first place. This is a concept that a brilliant ancient Greek thinker named Archimedes figured out over 2,000 years ago, and we now call it Archimedes' principle. The story goes that he discovered it while taking a bath, and he was so excited he ran naked through the streets shouting, "Eureka!" which means, "I have found it." So what did he find? He realized that when you put an object in water, the water pushes back against it with a force called buoyancy. Whether something floats or sinks depends on a battle between two forces, the weight of the object trying to pull it down, that's gravity, and the upward push of the water, buoyancy, trying to lift it up. Now, here's the key, the strength of that upward push is equal to the weight of the water that the object displaces, or pushes out of the way. Think of it like this. When you get into a bathtub, the water level rises because your body is displacing, or moving, a certain amount of water. The water you displaced has weight, and the water is effectively pushing back with a force equal to that weight. So, if the object weighs less than the amount of water it displaces, it will float. If it weighs more, it will sink. It's not about the weight alone, it's about the weight relative to the volume of water it's kicking out of its way. This is why a gigantic, heavy steel ship can float. It's not solid steel, it's mostly empty space filled with air, so its overall density, its mass divided by its volume, is actually less than that of water. It displaces a huge amount of water, and that water pushes back with a gigantic force that holds the ship up. An apple works on exactly the same principle, just on a much, much smaller scale. Now, let's get back to our apple and its secret 25% air pocket. An apple isn't just a solid block of fruit material. If you were to cut it open and look at its flesh under a microscope, you'd see that it's made up of millions of tiny plant cells. And these cells aren't packed solid, between them are countless tiny air spaces. This is part of the apple's tissue structure. Furthermore, right in the core of the apple, surrounding the seeds, there's a more significant pocket of air. This isn't a mistake or a defect, it's a crucial part of the apple's biology. This air space is a remnant from the flower the apple grew from. The apple blossom had a part called the ovary, and after it was pollinated, the walls of that ovary grew and swelled into the fruit we eat. The seeds developed inside, and the space around them filled with air. So, from the very moment it starts growing, an apple is designed with buoyancy in mind. This air dramatically lowers the apple's overall density. Let's do a little imaginary math. Imagine an apple has a volume of 100 units. If it were solid apple material all the way through, it would be relatively heavy for its size, and it might sink. But because 25 of those units are filled with air, which weighs almost nothing, the overall weight of the apple is much less than if it were solid. Now, when you plop that apple in water, it displaces an amount of water that has a certain weight. Because the apple itself, with all its air pockets, weighs less than that amount of water, the water wins the battle. The upward buoyant force is greater than the downward force of the apple's weight, and so it pops right back up to the surface. It's a perfect, natural demonstration of physics in action. This isn't just a fun party trick, it has real-world implications that humans have used for centuries. The most famous example is probably the game of bobbing for apples, especially popular around Halloween. People fill a large tub with water and toss apples in, and players try to grab one with only their teeth. The fact that the apples float makes the game possible. If they sank to the bottom, it would be a very different, and much more difficult, game. But on a larger scale, this principle of buoyancy is used in the food industry. In large processing facilities where thousands of apples are handled, they sometimes use water flumes to transport and sort them. The apples are poured into a gentle current of flowing water. The good, healthy, undamaged apples float and are carried along to the next stage of processing. The ones that are rotten, spoiled, or have significant internal damage often have different densities. They might have lost moisture or have more internal rot, which can change their density and cause them to sink. This provides an easy, automatic, and efficient way to separate the good fruit from the bad without needing complex machinery or manual inspection for every single apple. It's a brilliant, low-tech solution powered entirely by basic physics. You can even see this principle at work with other fruits and vegetables. Try this experiment in your own kitchen. Get a large bowl of water and test different pieces of produce. A dense, solid potato will likely sink like a stone. A zucchini might sink too. But what about an orange? You'll find that an orange with its peel on will float beautifully. But if you peel that same orange, removing its porous, air-filled skin, it might sink. A lemon often floats, and a pumpkin, which seems huge and heavy, will actually float because of all the empty space and air inside it. This is a great way to see how different structures lead to different densities. It also helps explain why some things we think should float, don't, and vice versa. It's a perfect reminder that things aren't always what they seem. Our eyes can trick us into thinking something is too heavy to float, but the real answer lies in the hidden world of its density and structure. So, the next time you're about to take a bite of an apple, or you see one floating in a bowl, I want you to take a second to appreciate it. You're not just looking at a piece of fruit, you're looking at a marvel of natural engineering. You're holding an object that is a perfect balance of solid food and life-giving air, a design that allows its seeds to potentially travel by water to find a new place to grow. You're witnessing a simple, delicious example of a physical law that governs our entire world, from the smallest apple to the largest aircraft carrier. It's a reminder that science isn't just in a textbook or a lab, it's happening right there on your kitchen counter. It shows us that the world is full of hidden wonders, and sometimes, the most extraordinary secrets are hiding in the most ordinary objects, just waiting for us to be curious enough to ask, why? So, go ahead, be a scientist today. Drop an apple in some water and watch the magic of physics unfold right before your eyes.